Hi, my name is Angus Robinson. I'm the Marketing Manager at the Anritsu Short Range Wireless Business Unit. Today I'm going to show you how easy it is to test the performance of the wireless LAN radio on a smartphone, such as an Apple iPhone, using the Anritsu MT8860C wireless LAN test set. So let's have a quick look at the setup that we need in order to measure the wireless LAN radio performance. Here we've got the Anritsu MT8860C. The RF output is connected to the shielded box where we'll put the iPhone in order to make measurements. The shielded box is important because without the shielded box, measurements could be affected by other wireless LAN radios in the environment. On top of the 8860C we've got a PC which is running the LANLook software. LANLook is supplied with the 8860C and is the standard user interface that's used for configuring the instrument and for displaying measurement results. Okay, in order to get started, the first thing we need to do on the smartphone is enable the wireless LAN radio. And when we've done that, it's also a good idea to disable any power save modes and any screensaver modes that there are on the smartphone, because this makes measurements run more smoothly. Okay, I'm going to put the iPhone into the shielded box, and what we'll do now is we'll go over to the LANLook user interface and I'll show you how to set up the 8860C to act as an access point and to start making measurements. First select the standard, in this case 802.11g, and then we need to select network mode under test mode. This is the test method we're using where the 8860C acts as an access point to control the iPhone whilst we're testing it. Then select the channel that we want to do the testing on, and finally the data rate that we want to do the testing at. Power levels for the 8860C transmitted packets and the expected power levels of the iPhone transmitted packets also need to be set. Of course we need to allow for the path loss in the test fixture, so we go to path loss settings, and in the pop-up window here, selecting channel 6, we enter the path loss, which I know to be about 26 dBs for this fixture. Add channel 6, make sure that the path loss is enabled and press OK. Now we need to make the 8860C work as an access point and enter an SSID that we'll see on the iPhone screen when we're setting up the network. In this case I'll enter 8860C tester. Another thing we need to configure is the beacons. I'm going to select the operational rate set to be single, which forces the iPhone to work at 54 megabits. And then in the power save settings field, enable all three options, and this inhibits the iPhone as much as possible from going into power save modes during testing. Now that we've set up the right configuration for the access point, we create a network, and we now need to go to the iPhone screen where we can see the network appear on the available networks. Select the 8860C and close the lid of the screened box so that we have isolated the iPhone from any other wireless LAN networks that may happen to be in the environment. Back on the device tree, we now get the MAC address of the iPhone and confirm that we want to connect to that specific device to make measurements. Now we're ready to make measurements of the receiver and the transmitter. First we'll do receiver testing. Select Unicast. Typically there's no need to change the packet structure from the default settings, so we'll move on to do a fixed level test at -50 dBm. Pressing run continuously causes the 8860C to continuously send 500 packets to the device under test receiver. The 8860C counts the returned acknowledged packets, and that enables it to calculate the packet error rate test. As you can see, the trace is a bit spiky. This is caused by the phone either going off roaming or going into a power save mode. Now we'll do a sensitivity search, and we can set the start and the stop power levels for the test. Having done that, pressing run causes the 8860 to step the power in 1 dB steps into the receiver, building up a trace of the receiver sensitivity. Again, there's a couple of spikes in the trace due to the phone either going into power save mode or roaming. Below the graph there's a table showing the specific results for each test level. Again, I can change the test to another standard or to another channel if I want to. Now I'll move on to transmitter testing. The simplest way to do transmitter testing is to use the auto configure feature, so I just press auto configure here and then press run continuous, and you can see immediately the three results windows are populated on the right hand side of the display. The top window shows the power burst profile, and the table below the trace shows the average peak power and the rise and fall time. The next window down shows the spectral mask profile performance, again with a table giving numeric results for each mask segment, and the final window gives us the EVM constellation diagram with associated numeric results. If I just stop the measurement, I can change the data rate to, for example, 18 megabits per second. I may need to reassociate the phone and press auto configure again, press run continuous, and now I get results for the 18 megabits per second data rate. I hope that demonstration showed you just how easy it is to test the wireless LAN radio on a smartphone without any special software from the smartphone manufacturer. If you want to find out more information about the MT8860C, please visit our website at www.anritsu.com. Thank you for watching.